So we had left off in class talking about our real number system, and you guys were able to define a couple of these letters here. So I'm going to go ahead and start at the smallest subset and go out to the largest. And of course we have our weird one on the outside. So we have in, and we said that that would be our natural numbers. And natural numbers, very simply, they're counting numbers. So anything that you can count, so I'm going to write that here in a circle. I'm just going to abbreviate the number symbol. There we go. So they're counting numbers. So if you count using your fingers, well, you would start with 1, 2, 3, 4, and you can pretty much count anything. So I'm going to give that example here. Like I said, I'm going to give 2 examples, and then you put another 2. This will be very easy. So obviously, I'm going to put the number 1 and the number 2. So I would like you guys to go ahead and put another example here and another example there. So again, natural numbers, that's simply counting numbers. Now, once we have our counting numbers, we can move on a little bit more forward, and we're going to move on to W, which we said were whole numbers. So let me take a look here. I'm going to draw the W the way that I showed you guys in class, like that, W. And you can color it in if you want. So those are whole numbers. Now, specifically whole numbers, the difference between whole numbers and natural numbers is it takes the natural numbers, so I'm just going to write that in. There we go. It's the natural numbers and 0. That's all. So you take all of these numbers and include 0. So 2 examples obviously would be 0, maybe 47. Why not? And I want you guys to go ahead and give me an example of another whole number and another whole number. Okay, let's go ahead and continue. So we start off with our counting numbers, our whole numbers, and then we moved on to Z, which we said were integers. And we were talking about that Z. That Z really doesn't make sense for the word integers, but hey, it is what it is. So, integers. Now, the difference with integers are both positive. I'm going to rotate this around a little. And I'm actually a little bit lazy, so I'm going to go ahead and just draw the symbol. Both positive and negative whole numbers. Okay, so in that case, an example of a positive number, I could use maybe, I don't know, 12. And an example of a negative whole number might be negative 7. Okay, so now again, I want you to give me 2 examples. Okay, let's move forward. Now we're moving on to Q. Now, with our Q, that one was giving us a little bit of trouble. We couldn't think of a word that began with Q. But then we talked about the word quotient, and we came up with the word, the subset, rational numbers. So the way that you can remember the Q think of quotient, and you should think of a ratio. All right. That's where your Q can kind of help you with remembering that it's rational numbers. Now, rational numbers will actually be integers. I'm going to scoot that down, sorry. And that's the subset that has the Z. Integers and decimals or fractions. Now, in particular, these decimals, let's see where I can fit it. I guess I'll continue going around. These decimals must be repeating or terminating. Now, terminating, that means that it has an end. Oh dear, my pen is going out. Sorry. There we go. But it has an end. All right. So let's think of an example of a rational number, a ratio. So one number that I'd like you to think of will maybe be 0.1. Now, this is a decimal, okay? It is terminating, so that means it has an end. And as a matter of fact, this decimal is equivalent to a fraction 1/10. Okay. Another example. Let's see. Well, actually, I think I'm going to give you 3 examples here because I want to cover a little bit more. It also includes integers. So integers are positive and negative whole numbers. So I could even include, I'm going to put a comma here just so you can see the difference. I don't know, maybe -5. That's a negative whole number. And, ooh, I want to do a repeating decimal here for you. How about, let's do this one positive. 0.6666. We're going to put that little bar over. This 6 is repeating. So since it repeats, it can actually be converted into a fraction. You guys should be familiar with this fraction. This one is 2/3. Okay, so I gave you 3 examples. I'm going to put a comma here. I want you to give me 1, 2 examples. All right, just 2. So that's 2, 4, 6, 8 examples that we're up to. Then we got up to our R. So our R, oh, I'm off a bit. I'm missing a color. Oh, how about we do it in dark green? Okay, so we colored this one in, and we said that this one is equivalent to all real, and we even drew that off to the side, 2 parallel lines, all real numbers. Okay, now, our numbers here is pretty much going to be everything within. Oh, actually, I'm going to pause on my examples here because there's something else that's inside of our all real numbers, and that was our I. And those are irrational numbers. So, gosh, I don't have too much space for this. Let me see. Okay, I think I'll go ahead and write it up in this corner.